You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
021 446 0567 011 883 0702. We are taking your SMSs on 31702 and 31567. Chris, good morning to you.
Good morning.
Thank you so much. Are you excited about the rugby? Are you interested in rugby at all?
Well, we're just saying this morning to our children, we'll be turning on the TV and exposing them to a bit of rugby action this evening, I think.
Oh, okay, that's fantastic. Well, rugby fever has hit South Africa as well. Let's start with this, the science story of the week. First ever in vitro human spermatogenesis. Yeah, must speak slowly. What's that all about?
Well,
is it IVF? What's it about?
Release came out from France just yesterday afternoon. And what they're announcing, and the reason that this has only just surfaced, is because they've been putting this out for a patent, which I gather must have been granted. But the idea of this is that they've got a technique here. This is a company called CaliStem, and the scientist who's doing this is Philippe Durand. And what they have done is to come up with a system that enables them to grow sperm in a dish. Now, this has for a long time been a goal of science, because there are lots of reasons why it would be helpful to be able to do this. People who have to go for, say, chemotherapy, which would otherwise destroy their fertility. Individuals who have not yet become fertile because they're prepubescent, say young boys who have to go for treatments that would otherwise harm their potential to have children in future. This technique can work on these individuals. What they've done is they have found a way to produce a three-dimensional growth system where you put into this culture vessel what are called the seminiferous tubules. These are the structures in the testis that enable sperm to grow. In those seminiferous tubules, they put cells called spermatogonia, and those spermatogonia are what produce sperm in the adult testis. Those spermatogonia are then nourished and grow in the seminiferous tubules, and they produce mature sperm. And it takes about 50 to 70 days to get sperm out, having done this. But the sperm do appear to be structurally normal. We asked them, have you done genetics on the sperm yet, to prove that they've got the correct genetic structure. Mm-hmm. They said they're still doing that. Nor have they yet proven that it's possible to fertilise a human egg with human sperm made this way, but they are making human sperm from human samples with their technique. So it looks really encouraging. So I'd say that's a pretty important breakthrough for this week.
And it's very interesting because often when we speak to Professor Shingai on our sex talk on a Friday morning, you get a lot of men who feel that there aren't any options for them if they suffer from infertility. I remember one of them saying he was told to stop smoking, to stop drinking, and that hasn't solved anything, and that a lot of the research is focused on women's infertility. Would you say that this is a great response or intervention to that?
Well, it takes two partners to have a baby, obviously, and sometimes when things go wrong, there are female factors that are responsible. Sometimes there are male factors, and at the moment, there's a lot we can do if there are female factors. There was much less we could do if there was a problem with the man's ability to make viable sperm. This is one option which it's certainly not going to solve all problems, because there will always be other problems such as genetic issues and so on and so forth. But this will take us a step closer to being able to help another proportion of people, assuming it all works. I mean, at this stage, this is an early announcement. They've only just shown that they can do this. It's going to have to go through a lot of safety checking and other things to make people realise or make people know that or reassure the public that this is going to be safe, and that's going to be in train now. It's going to be a few years yet, but certainly it's very encouraging because it does offer us another option for people who fall into the camp you mentioned, people who previously were told do sensible things like don't smoke and don't drink because that will help, but it's not always the answer, and this may give an additional, I suppose, tool in the toolbox for people to use.
Let's go to Christopher in Germiston. Good morning to you, Christopher.
Good morning, Reddy. Just a quick question, please, for Chris. If Chris can please explain what exactly is sleep paralysis. I've tried to Google it. It's just too scientific for me to read and understand it. I would like to understand, please, what exactly happens.
Good morning, Christopher. Well, the answer is when you go to sleep at night, periodically through the night, you go into a phase of sleep called REM sleep, rapid eye movement sleep, and this is when you dream. And you can imagine some people have extremely action-packed dreams, and it would be catastrophic if your body were able to respond to all of the signals that are buzzing around in your brain, because you could quite literally try to act out your dreams. So there's a region of the brain which has the job of stopping messages when you are dreaming from going out of the brain, down your spinal cord and making your muscles work. We think this is a region called the subcerulear region in an area called the brain stem, which connects your spinal cord to the upper part of your brain. And when your dream switch turns on to say, right, start dreaming, it also turns on this other area, which in turn stops those messages flowing out and stops your muscles working. Normally, when you stop dreaming and when you wake up, that area of the brain should disengage and you should get back all of your ability to make normal voluntary movements again. Sometimes, and it's pretty common actually, we don't know why, but for some reason this area of the brain fails to disengage abruptly when you stop dreaming, often when you're woken up in the middle of sleep, for example, if you have a nightmare or something, and temporarily, for a very short time, it stops the flow of voluntary information coming out of your brain to move your muscles, and so you literally, although you're thinking, I want to move, you experience a sensation that you cannot move and you're frozen to the spot. And this is frightening for some people because they think they've woken up paralysed. And then it passes and you go back to normal. So we think it's because the brain is a little bit slow, ungating or disengaging the paralysis circuit that normally stops you acting out your dreams, sleepwalking and throwing yourself out the window, which could otherwise happen.
Okay, that's Christopher. Thank you very, very much for the call. We're going to take a break and more of your questions I see on SMS and Twitter as well. Stay with us.
702 and Cape Talk.
The Naked Scientist.
0214460567 011 883 0702. Here's an SMS from Yvonne. Does urine have medicinal value that if used daily, internally or externally, as proponents of urine therapy claim? If so, why are people not encouraged to view urine as beneficial? That's from Yvonne.
Well, hello, Yvonne. There are some circumstances where urine can be beneficial. One of them is that urine usually is sterile. When it's made by the kidney and it's in the bladder, there should be a very low rate of contamination by microorganisms, and it can therefore be used to cleanse things because it's a liquid, although it's got unpleasant tasting things in it. As anyone who's ever had to drink theirs, people who, for instance, end up in the desert and almost running out of fluid, sometimes they resort to drinking their own wee. They would tell you it doesn't taste terribly good, but it will be sterile. Therefore, if you have a very bad injury and you have no other way of cleansing a wound, sometimes it can be used for that. Also, jellyfish stings, the nematocysts in the tentacles of jellyfish, they discharge under certain environments, but they can be inhibited or prevented from discharging the venom of the jellyfish into the skin under other chemical conditions. And you can achieve some of those chemical conditions with urine. So when people get stung by a jellyfish, sometimes weeing on the sting site can make it a little bit less uncomfortable. I'm not aware of any other grounds for using urine in therapy or otherwise, and I think actually probably that wouldn't be terribly pleasant because it's the stuff, after all, that the body's trying to get rid of. There's quite a high proportion of salt, there's a low volume of water usually, and a relatively high proportion of urea, and this is a very bitter and unpleasant tasting and smelling compound, so I'm not really sure what people would want to do with that, because at the end of the day the body has decided it doesn't need it and it's trying to throw it away, so putting it back into your body is probably not going to help.
Yeah, just leave it there, Yvonne. Just leave it there. Dan in Brits, good morning.
Good morning, Reddy, and good morning to the Naked Scientist.
Mm-hmm.
Reddy, I just want to know from the Naked Scientist that, through the bones that were found in the cradle of humankind,
Yeah.
I just want to know whether is there any possibilities of cloning that creature?
Cloning the fossils, cloning the Homo naledi.
Cloning it, meaning that,
I think we get the question. Chris?
Hello, Dan. Well, the answer is that to clone something, you need the DNA intact of that particular thing. And as far as we know, these remains are extremely old. They may be too old for intact DNA to ever be recovered from them. That said, scientists in Spain have managed to get sequences of the DNA from the Chamber of Bones there, which has got specimens in it that are, say, 500,000 years old. These remains at the cradle, we don't know exactly how old they are yet. The scientists haven't made a formal announcement. They're doing tests, as I understand it, at the moment. Now, one of their goals will be, undoubtedly, to check those remains because they are so pristine, to see if they can recover DNA from them. And DNA technology is getting pretty good these days. So, assuming they could get a complete genome from them, at the moment, it's not possible to just go from a genome into a clone, but in the future, I guarantee it will be possible to do that. And therefore, assuming you could get the complete DNA sequence of those individuals intact and in a linear fashion, in other words, all the DNA is in the right place, then theoretically, you might be able to clone them. I'd say it's a long shot yet, though.
Okay, thanks, Dan. Chris in Alberton, hi.
Hi, Chris. Hi, Rudy. I know that Andromeda and the Milky Way are on a collision course and that we don't have to panic because it's still like 3.5 billion years away. But when the Big Bang happened, surely everything should be moving away from a central point. So how is it that these two galaxies are now colliding?
Hi, Chris. Well, the universe is absolutely enormous, and you're right. 13.8 billion years ago, there was a Big Bang, and there was a release of energy. Ultimately, matter was made from that energy, and things have been expanding ever since, although the rate of expansion has changed a little bit. And yes, on average, everything is getting further from everything else. But at the same time, there are things which are, by chance, moving towards each other, because there will be some areas which, although the space is getting bigger, gravity is pulling on adjacent structures and moving them towards each other. So the universe is getting bigger, the material in it is generally spreading out, but in some cases the material under the influence of gravity is moving towards each other, because there was just random distribution of the movement and the momentum and the expansion in the early days, and that continues to be random today. And random is not everything going away from each other. Random is something's going towards each other, something's receding.
Okay, thank you very much. And we have an SMS here about bipolar and what causes, okay, it says, what is the difference, rather, between bipolar and post-traumatic stress disorder?
Okay, well, they are two quite different things. Bipolar disorder used to be known more commonly as manic depression. And about 1% of the population are affected, and it's much more common in families. So if you have a close relative who suffers with bipolar disorder, then you're at a higher risk of this happening to you. People who have this have a range of different symptoms, so you can't generalise and say it's always like this, but on average, what people tend to report is that they will have periods where they have enormous amounts of energy, creativity, they talk a lot, they don't really need to go to sleep. They may, after long periods of time without sleep, they may then begin to experience delusions where they might, for instance, think that they're God, or they might think that they are incredible at doing something, or they may get an idea in their head that they absolutely have to go and help the whole world by spending lots of money. And after this period goes on, then there is often a crash, and people will get very, very depressed, very, very low, and that takes a while to recover from, and then they become high or manic again. And some people, that happens quite quickly. In some people, they cycle much more slowly. In some people, they just stay in a state of near mania, that high sensation, pretty much permanently. Other people tend to be low most of the time and occasionally have highs. So it's very variable from one person to the next. It's quite hard to control, and it's very disabling for people who have it. But people who do have it tend to learn what the danger signs are for them, and then they go and get some help, or they know how to stop it manifesting into a full-blown manic attack or a depression phase.
I have a follow-up question. Oh, sorry, Chris, I beg your pardon.
Well, I was going to say we haven't told people what post-traumatic stress disorder is, because this is something very, very different. And in PTSD, this is a manifestation which occurs off the back of or in response to, as the name suggests, a particularly stressful episode. People who, for instance, are on the battlefield and they see horrendous things happen to their friends and colleagues. People who lose a close relative in front of them, someone drops dead in front of you, and especially if you're a young child, you're involved in a horrible accident. These sorts of things leave an indelible mark in the brain, and people will characteristically report that at the various frequencies after the event, they have flashbacks, and it's almost like a video or the action-packed movie of what they experience playing out in front of their eyes. and all of the sensations, the unpleasant feeling and the terror that went along with that sensation and situation all replays as well. And it can put people into a very fearful state when it's happening. It's very unpleasant and disabling. So they're two quite different things, but they're equivalently disabling in their own way for the people who suffer from them.
So my follow-up question is this. I do know that the exact cause of bipolar disorder is unknown, but there's several factors that may be involved: biological differences, inherited traits. I've also seen neurotransmitters, an imbalance that naturally occurs in the brain as one of the reasons. If that is the case, would the brain then of somebody who has suffered from bipolar disorder, when they die, would their brain be wired or have a different look and feel from one who hasn't suffered from this disease?
When you look at the brain of someone who has a mental illness, occasionally you can see differences. In people who have had schizophrenia, for example, there are occasionally structural differences that are visible to the eye. In other words, you don't have to take a microscope to see a difference. Sometimes the brain shape is a bit different. Sometimes some areas of the brain are smaller than they ought to be. Now, what we don't know is whether that is a cause of the schizophrenia in that person or a consequence. For the most part, though, and for the majority of mental illnesses, you will not see a gross difference in the structure of the brain in someone who suffers with that condition and someone who doesn't suffer with that condition. And this is probably reflecting the fact that what it takes to cause these disorders is a tiny amount of wiring difference in the brain, or a chemical imbalance, which won't necessarily affect the entire structure and shape of the brain, but could, as you say, lead to differences in levels of different neurotransmitters, or the sensitivity of brain cells to different neurotransmitters in different parts of the brain. And it's interesting you highlight this, because one way that people are managed when they have bipolar disorder, manic depression, is that you give them mood stabilizing chemicals. These include a drug called sodium valproate, which is very good at keeping the level of the brain chemistry even, and also the chemical lithium, the metal, is also used. It's a very nasty drug because it has a very narrow window of safety. It's very easy to take too much lithium, and so people try not to use it if they can avoid it. But it too stabilises the chemistry of the brain and helps people to not have those big departures in their mood.
Let's go to Khadi Feli in Rustenburg. Good morning.
Morning. Thank you for the call. I just wanted to know, can you please tell me, do carnivores feed on each other? That is, can a lion hunt a leopard, or they only feed on herbivores? Just interested to know.
Okay.
I didn't catch the question.
Okay. Do carnivores ever feed on each other, or they just hunt herbivores? Would a lion hunt and feed off what did you say, Khadi Feli? Yeah.
Yes, I want to know if can a lion feed on it. And if not, what's the reason?
Okay. Do carnivores ever hunt and feed on each other?
I stood on a slug the other day, and I came along, and there was the squished slug this morning, and there's 3 other slugs eating the squished slug. So that's an example of traditionally a herbivore that will turn into a carnivore. But the answer is it depends on what the modus operandi for that animal is. Some animals are carnivores which they will go for something, they will catch fresh meat, they will eat it, and then they move on, and then the carrion feeders and scavengers come in and finish it up. And sometimes one of those will start a fight, and they'll quite happily eat each other as well. It depends. Some animals tend to go for fresh stuff if they can get it, and they'll scavenge if they can't. If you make any animal hungry enough and give it enough stress in its life because the environment is not providing it with enough food, pretty much anything will eat anything else just to survive, because the survival instinct is so strong.
Thank you very much, Hadifel. A very interesting question. Chris, have a lovely, lovely weekend. Enjoy the World Cup with your little ones, and we'll talk to you next week.
I should do my best, and you. Yeah, well, good luck.
Good luck to you.
Bye, Rudy.
Yeah, tonight, and we're tomorrow. So we're going to podcast this conversation with Chris, as always, and thank you for taking part.